AET-114, Chapter 25, Pulse Waveforms and the RC Response. So we're going to become familiar with these terms, uh, such as pulse width, rise and fall times, and tilt. Calculate pulse repetition rate and the duty cycle of any pulse waveform. Become aware of the parameters that define the response of an RC network to a square wave input. Understand how a compensator probe and an oscilloscope is used to improve the appearance of an output pulse waveform. So, what is a pulse? Ideally, this is what a pulse looks like. It has a rising or leading edge, and then it has a pulse width. That rising edge happens at time t1, pulse width is tp, and then the falling or trailing edge happens at t2. The amplitude of the pulse is on this axis here. In this case, it's a voltage pulse, and there's a time axis here. Actually, in reality, a pulse looks more like this. It doesn't go straight up, but it curves up and then curves up to its peak or its amplitude. And again, you have the same parameters here: the amplitude, the pulse width, and then you have T1 and T2, and they're defining T1 and T2 as when it gets halfway to its maximum, which they're calling V1 here. So 0.5 V1 is where T1 is, and also where T2 is. Okay, some practical examples would be like your TV remote or garage door. Any kind of remote control sends out a pulse. For the purposes of this text, the amplitude of a pulse waveform is the peak-to-peak value illustrated in these examples. So, like, this is the amplitude here, all right? And this would be the amplitude here. It's the peak-to-peak value. This would be the amplitude for a negative pulse, so it can also go in the negative direction. All right. The pulse width or pulse duration is defined by a pulse level equal to 50% of the peak value. The baseline voltage, VB, is the voltage level from which the pulse is initiated. So here, VB is at 1 volts. Here, VB is at 0 volts, and here, VB is at negative 4 volts. A positive going pulse increases positively from the baseline voltage, whereas a negative going pulse increases in the negative direction from the baseline voltage. So this would be positive going, this A, and then this would be negative going. The rise and fall time are defined by the 10% and 90% levels as indicated in figure 25.5. So this is the rise time. Okay, it's T sub R, and then T sub F is be the fall time. This is the 90% level of V1, which is the peak amplitude, and then this is the 10% level. And then the percentage of tilt, it would be if you have a tilt in your pulse like this, it would be the amplitude of the rise, and this is the amplitude of the falling edge. So you take the difference between those two, divide it by V, and that's the percentage tilt. V is the average value, so V1 plus V2 divided by 2 is V. That's what this V is up in this equation.